take like 29 or whatever. All right, let's talk about magic methods. So magic methods are pretty complicated, and I have debated over the size of this video, but I think I've decided that we're going to understand 5, count them 5 magic methods. We already, I feel like, have a pretty good handle on the init method, so I'm just letting that one roll here. So I've got an init method, I've got a class that represents a bank account. Should be noted, there's probably a really shit way to do this. My guess is nobody represents an account this way. I'm just using it because I need something with some pieces. So let me talk about kind of the idea of magic methods. So magic methods are things that Python implements on its own. So that what that means is that there are various ways to call these things kind of in the background of Python. You might not even have realized that you're doing them. So the init method, right? We never explicitly call the init method. We just say, all right, make me an account, right? And then this goes through and makes an account. Well, the way it makes an account is it calls the init method, or the new method if you, reasons. Let's go with the init method. So some of these other methods are also called by Python. So the string method is called when I either string typecast or when I try to print. The add method is called when I throw a plus sign in between two things. The radd method is also called when I throw a plus sign in between two things, but a little differently. We'll get to that. The equals method is called when I throw those double equal signs. That's a comparator method. And the int method is a typecast. So I've got a couple different things. I've got a representation method. I've got a couple operations magic methods. I've got a comparison magic method, and I've got a typecast magic method. There's one more kind of thing here, loosely, which is the like iterate through it magic method, but that one's just a little bit complicated for the first day, so we'll skip it for now. All right, so first things first, I'm going to make up some variables here. So I've got my 2 accounts that I created here. I'm the owner on both accounts, so that's what I passed to the holder. So I've got this string, right? That's the holder. You can see my kind of doc string here. In fact, actually, if we hover, we can just read it. So I've got this thing that represents a bank account. It takes a number, that's an integer, that's the account number. It takes a holder, that's the name of the account holder, it's a string. It takes a balance, that's a float. I guess I should probably do something like this. So say I have a checking account. It's number 1234. It's got $450.00 in it. And I have this other account that is my savings account. It's number 5678. It has this $375.79 in it. So, first things first, let's write that string method. So the way we're going to write that string method is we're just going to go into our object and we're going to write a string method. That's going to take self, and that's it. This thing needs to return a string. No matter what you want to do here, it has to return a string. Python won't let you do it anyway. Any other way. It'll yell at you. Trust me, I tried. I had a thing I really, really wanted to work, and it decided not to. So this has to return a string. But it can return whatever the hell string you want. So I'm going to make a string for this thing to return. I'm just going to have this return a formatted string that's going to say account self.number. So we're going to go get the account number. Has, I suppose, I guess I should say held. Nobody says held. Owned by self.holder has a balance of self.balance. It'd be easier if I could type. Okay, so we're gonna hit run. Right now I expect this to do bupkiss because I created those 2 objects but I never called anything. So I'm seeing some problems. Those are just probably linter issues. Yep, linters. All right, so let me call that string method. Now, the funny thing about the built-ins, the magic methods that also known as dunder for double underscore, the funny thing about magic methods is they don't actually really get, like, you don't call them explicitly. You do stuff like, say, I'm going to print Joe checking. Now, if I hadn't defined this, my expectation is that that would just print out a memory address. But I can see, now that I've got this returning a string, it prints out something interesting. If I comment that method out and run this again, it's just going to print this account object and a memory address. Now, I really would rather not have it do crap like that. I want it to print more nicely. So this is how I'm kind of getting around that. This one you've probably seen me use before. I figured this one out, the string method or the repr method. They're a little different. The string method is the one that print calls. Repr gets called by some other stuff like Jupyter notebooks and stuff. I'm not going to really harp on the difference, and frankly, you should just know that they're both there and a little different. So I've got my string method. That's working. Let me work on my next one. I'm going to work on adding. So I'm just going to do the exact same thing, right? I'm writing definition the way I want to add. And this is going to get a little bit weird. So the question is, what do I want to be able to add to accounts? Well, frankly, I want to be able to add to accounts a balance, right? I want to be able to add a number to an account. Okay, so here's what I'm going to do. I'm going to say this thing should take a self and a other. Now, other here isn't a keyword. It's just me thinking. So first things first, I'm just going to get this working for numbers, right? So I'm going to say if is instance other and int. So this is really just a type check, right? I'm checking if the other thing's an integer. Then what we'll do is we'll do self.balance plus equals other. So if I pass this thing an integer, we're gonna go ahead and we're gonna add that integer to the balance. Now it should be noted that I'm cheating a little bit here. Maybe just to be explicit, let me write this. Okay, so we're adding this to the balance and then we're overwriting the balance, right? So let's check and see that works. So we're going to do Joe checking plus 20. And then we're going to see if we can print out Joe checking. Now the interesting thing, right, is that I didn't actually have to reassign this, right? Oh snap, it just freaking works. You guys see that? So I just increased the balance by 20 just by putting Joe plus 20. Now why did that work? Well, it worked because it's storing it in an object, right? So it's actually changing the object itself, right? It's going in there and it's changing that balance amount. That object is persistent, right? And when I go look at it, right, this print is calling the string method on this account object. And that account object initially has $450 in it, and then after I've added 20, it has $470 in it. Now, that's a little wild. Here's the really weird thing. If you wrote this in the other order, this will now raise a type error. So I can see that it's saying that unsupported operand for plus between integer and account. What that means is that the add method that's in the integer object doesn't know how to deal with adding an account. Of course it doesn't. Why would it? I just friggin' made an account up out of nothing, right? Like that thing didn't even exist 20 minutes ago, much less work, right? So the integer object is going to have no idea how to do this. So if you want this to work, and this is our kind of special bonus feature, what we're going to do is we're going to define right adding. So right adding is another magic method. And all I'm going to do is alias right add to add. And actually, no, I'm going to be explicit about this. So I'm not going to do that. So I'm going to check if the other thing is an integer. And remember, this is right adding. So this is when the account's on the right, the other thing's going to be on the left. A little confusing. Yeah. And then I'm not sure if the video is mirrored here, so that might look real stupid. All right, so I've got my balance that I'm increasing by this other. Now let me just run this, and we'll get that it goes up by $20 again. Woo! Cool. So no more unsupported operand types. It should be noted here that I could make these act differently. Right now, these are just carbon copies of one another, which is a little bit stupid. It'd probably be better to just alias this, but let me not do that for right now. The other way I'll show you how to do it. The other way you could do this is you could just call self.add on other. Yeah, that should also work. Yeah. So you can just explicitly force this thing to do the other method. If you want them to act the same, this is maybe the easiest way to do it. Okay, I lied. I'm going to do it that way. There's another way that you could actually just re-alias it, but I'm not going to show you that one. Okay, so we've got it adding. We've got it right adding, which is pretty cool. In this case, I think actually that doing $20 plus Joe checking is probably a shit way to do this. Probably shouldn't have implemented a right add method, but what the hell. All right, let's talk about equals. So this is our comparison method. So what I need here is another count. So I'm going to make, actually, why am I doing this? I'm going to make Joe checking again. And I'm going to suppose that this got read out of the database in two different ways and amalgamated. So there's two different accounts here, right? One of them's got a different holder name than the other, but the account number is the same. So this happens every once in a while that you're, pulling data in from a couple of sources, and there's some kind of unequivocal key, like the account number in this case. And you want to know, is this account the same as this account? Well, unfortunately here, what's going to happen is even if they have the exact same information in them, let's check. So let's just comment those puppies out because we don't really need them. Let's print Joe checking equals Joe checking. 2. Okay, so I get false even though these two accounts have exactly the same information in them. I'd really rather if it didn't do that. The reason it's doing that is that it's defaulting to the object level equals function, and the object level equals function checks to see if they have the same memory address, and they don't, right? They're in different places, they're different objects. Even though they are exactly the same in their contents, they represent different kind of places in the memory. So what I want to do is I want to overwrite that behavior. I want it to just frickin' check, man. So what we're going to do is we're going to define the way we check equality. And the way we check equality is we're going to say if is instance other account. So first things first, I definitely don't want it to check if two things that aren't accounts are equal, because it definitely won't work. So the else for this is going to be return false. Right, so if they're not both accounts, it should definitely just return false. If they are both accounts, what it should do is it should check if all the information is the same. So the way it's going to check if all the information is the same is we're going to say if self.number equals self, not self, but other.number. Right, so if the account numbers are the same, and self.holder is other.holder, and why is it highlighting strangely? Do I need these guys? Probably not. Oh, I'm an idiot. It's highlighting self because self's a reserved word. And self.balance equals self. Oops, still not self. Still other.balance. And now this is a little weird. So right now, what I'm checking is I'm checking whether it's the exact same in all three attributes. Now, really, probably in use, I should maybe only check the number. But this is the cool thing about the equals function. You get to decide what equality means. So you might only care if the account numbers are the same and the account balances are the same. If the holders are different, well, that's something they have to sort out, right? That's like on your cell phone. Right? When you have access to an account, you're the account holder for that, right? So if you and your significant other both have access to your bank accounts on your mobile apps, you might both be holders of that account. And really all I'd be interested in is this account the same as that one, right? I might not care about the holders. In any case, I've got my three conditions that I'm checking. And if they're all the same, I want to return true. And otherwise, I want to return false. Now, this is a bit dumb. It's really dumb to misspell false. This is a bit dumb because really I'm going through kind of a whole bunch of if-elses, and I really could just have one return line here. I know this is a bit much. Like this is a bit verbose, but I want to be really clear about what's going on. So let me run this now. Let's see. See how it switched to true? Okay, so what if we had the account holder information different? Then it would return false. What if I wanted that behavior? Well, then I'd just take this condition out of there. I'm going to leave it in because I think I want all three things to agree, but, you know, you do you. Okay, so that's equality. Now let's talk about this integer method. So this is what you get when you typecast to an int. I would like to be able to typecast these accounts to ints. So let me just check how I can do that. First, let's check that that's not working. So this is what happens. This is how you get an integer, right? When you just call int, that typecasts, right? Okay, so the way it typecasts right now is going to say, look, it needs to be a string, a bytes-like object, or a number, not an account. Like, stop it, basically. Okay, so let me force it. So what I'm going to go in here and do is I'm going to define the integer method. Int Why is it pretending that int isn't a regular dunder method? Sorry, quick moment of panic. All right, so to int typecast, we're going to take self. And what we're going to do is we're going to return the integer casting of self.balance. Now, I only think that floats have an integer casting. I'm not totally sure this is going to work. Let's try it. Woo! Cool. All right. So what happened there, right, is the way we cast an account to an integer, right, is we just took the balance and cast that to an integer instead of the rest. Now, this might not be the behavior you want. This is the behavior I chose to implement. There's an interesting concept that I think we should maybe be thinking of here, which is the principle of least astonishment, which is actually a really cool idea. So the idea here is that if you're doing something that is in any way surprising to the user, you might want to rethink it. Now, I'm not sure that the integer method I just wrote would actually be a good idea, because I think that integer method is probably a little astonishing. Seems like a stupid way to implement it to me. Now, it might be the way you want it. It's what I chose to use as an example just because it's quick and it's easy. But you might want to think about the principle of least astonishment. That is, by the way, the reason that I'm not particularly concerned about writing doc strings for these magic methods. Like, you're not going to catch me writing extensive doc strings for these because they just kind of act the right way. I might write one for equality. I might write one for integer because those are a bit surprising. But I'm not going to write one for add because that just flat makes sense. I might not write this right add because, frankly, I think that what I did there, where it adds 20 plus Joe's checking account, I think that's a little weird. I think that one might be better left unwritten. That said, I think it's a useful example. I hope you've taken away some understanding of magic methods from this video. They are so freaking useful. Let me know if there are magic methods that you're specifically wanting to see more use of, and we'll make some more videos. I do have one about iter coming up, so look forward to that.